Okay, good morning, class. I know that it's really hard to be doing distance learning, and I know it's hard to teach yourself math. So I'm going to make just a little video of us talking through the notes that hopefully help. And I just really wish I could be in class teaching with you guys so I could see your beautiful faces, but one day. Okay, so stay strong. Let's go through these analyzing graphs notes. And if at any point you're like, hey, Ms. Larson, I have no idea what you're talking about, go ahead and send me an email, shoot me a comment, send a carrier pigeon, whatever you need. Just know that I'm here for you and we're in this together, okay? So let's look at our first slide of the analyzing graphs notes. So first of all, we want to look to see, when we're analyzing graphs, these key features. We want to look at the x and the y-axis. What does the x-axis represent and what does the y-axis represent? So remember, x is short and fat, so x is the side-to-side axis. Y is long and thin, so it is our up and down axis. Okay, so we want to look to see what do the x and y axis represent. We also want to look to see, as x is increasing, what is y doing? Is y also increasing, or is y decreasing? We also want to see if there are any points where the graph is just constant, where it's not going up or down, it's just going straight across. Okay. We also want to look to see if it's intersecting the y-axis. So we have our y-axis, look at the graph. Okay, where is it intersecting the y-axis? And whatever that point is, remember that's the y-intercept. You guys did that a couple weeks ago, so you should be masters of that by now, right? Okay, we also want to look to see where is it changing from increasing to decreasing, and vice versa. We also look to see if it's linear or nonlinear. Remember, linear means that it's a straight line. It's in the name. Linear, linear, the line. So we want to look, is it a line or is it kind of curvy? Okay, so let's look at the next slide here. Okay, this is an example that we're going to look at. And you see, first we want to do is check the x and y axis. What do they represent? So let's look down here at the x-axis. It looks like x represents time. So this 1 means 1 hour, 2 hours, 3 hours, and so on. Okay, let's look at the y-axis. It's the distance from home. Oops, that was a real bad. Distance from home. And it looks like it's in miles. So we can kind of start thinking about what kind of situation this graph is representing. Okay, so once we have it figured out of what the x and y axis represent, then we can start looking more at the features of when is it increasing, when is it decreasing. Okay, so if we look at this, we're going to read from left to right. Okay, left to right. So if you, let me grab this. Okay, so we're going to just kind of go step by step through this. We're starting at 0 miles from home. That's right here. Okay, 0 miles from home, that's our y-intercept. You can see here. Now we're going to increase from x equals 0 to x equals 2. So if you see, like, we're looking at where x equals 0 to x equals 2, and throughout that time, the graph is increasing. It's puff, puff, positive. You remember that from Slope Tube, right? And then it looks like from x equals 2 to x equals 3, the graph is decreasing, as you can see here. See, from x equals 2 to x equals 3, so we're looking in this section right here, the graph is decreasing. And then we're going to look at this next segment. It's increasing. How long is it increasing? From 3 hours to 6 hours. So over those 3 hours, the graph is increasing. And then from 6 hours to 7 hours, it's just solid, just constant. From 6 to 7, x equals 6 to x equals 7. So we're right here in case you want to follow along with this thing. Okay, and then we have from 7 hours to 8 hours, we're increasing once again. So you can see that there. And then we're decreasing from x equals 8 to x equals 9. And then it's constant from x equals 9 to x equals 10. And then that's basically where our graph stops. Okay, you don't need to draw any of these lines in. I just wanted to used to hopefully show you where I was at when I was talking over here to this, okay? So if I'm gonna clear this, we're gonna go on to the next slide and we're gonna now analyze it, okay? So we can interpret what is happening. So I'm gonna move myself up here. Okay, so we wanna start at the y-intercept. We're starting at 0 miles from home, right here. So here we are, We're gonna imagine we're taking like a road trip because we're going time and distance from home. So we're gonna start here at 0 hours, 0 miles. And for the first 2 hours, we're driving away from home. It looks like we get to be 100 miles from home in 2 hours. Okay, in the car for 2 hours. Oh no, perhaps we forgot something. So for 1 hour, we drive back towards home. Let's say we forgot our left shoe. So we're like searching all through the car for this hour. Where the heck is my left shoe? Right at hour 3 of our drive, we realize, wow, my shoes are here the whole time. It was right under the table. Or you don't have a table in the car, right under the seat. Okay. So then you start driving back, got to make up for lost time. You drive. Oh, so it looks like now we're at 6 hours. So we've been driving farther away from home for 6 hours. But this is just like the past 3 hours here. Okay. So for 3 hours, we're increasing, getting farther from home. Our total trip is 6 hours. Okay. And it looks like we are now 200 miles from home. We're tired. We've been in the car for 6 hours. So we stop to take a lunch break, stretch our legs a little bit. That's a constant from x equals 6 to x equals 7. And then we're going to start driving again for 1 hour. So that's where it says increasing from x equals 7 to x equals 8. And realize, whoa, we passed our destination. So then we are going to come back down. We're driving back towards home. So we're decreasing from x equals 8 to x equals 9. And then we hang out for 1 hour. That's where it's constant from x equals 9 to x equals 10. Okay, so that's just us analyzing the graph. We don't know if any of this actually happened, but it kind of helps us put a story to the graph. Okay, so now if we go to the next slide, we're going to look at another example, and this is a graph of the confirmed coronavirus cases. This is worldwide, starting in January and going to the end of March. As you can see, the x-axis here are the months, and the y-axis is the total confirmed cases. So at the beginning of January, we're looking at, right at the beginning of January here, 300 cases. So that's our y-intercept. As we see, as time goes on, so as we move to the right of time, following January, oh look, mid-February, there's a little bit of a spike. It goes up pretty steep right there. So I don't really know what happened there, but then we're just like, slow increase to the number of cases. And then mid-March, this is about when we were deciding whether, or that was when we went to spring break and we didn't really know what was going to happen after spring break. So we're right about here and see how, whoa, that was a very steep increase. So the rate of change was really high here. So we're gaining a lot of new cases towards the end of March here. And since this is not a line, it's going non-linearly. Okay, so there's a lot of data out there right now on the coronavirus and what's going on in our world right now. So being able to analyze graphs will help us understand the situation more and understand what the heck is happening. Okay, so I am going, this is it for the analyzing graphs. If you have any questions, comments, concerns, please let me know. Okay, I love you guys lots, miss you all lots. Stay safe, stay well, wash your hands.